This is a picture of the Saturn V rocket. You've probably seen stuff like this before. But how does it work? So rockets are really unpopular right now because of the SpaceX launch, and I want to give if I was on the TV, this is the explanation I would get so that you can understand the basic idea behind rockets. Here is the Dragon 2 rocket launch. This is not the one, this is a abort test they did. This is not the one that's going to be a crewed mission to the International Space Station. But the Dragon 2 is the capsule on top. The rocket itself is the Falcon 9 Block 5. I looked that up. I don't really know anything about it. But it does have a thrust of 7.6 million newtons. That's a lot. Okay, just as a comparison, if you took a textbook and held it up with your hand, you're pushing up with about 10 newtons of force. So just give you a little comparison of how that works. Giant forces. Okay, so let's start with force. What is a force? You will often see something like this where, someone's pushing on the wall. The force is a push or a pull. So if I push on that wall, then I'm exerting a force on it. Another way to think about this is the spring here on this mass and spring. That spring exerts a force on the mass, and we can get this motions like that. But the important thing here is also that forces come in pairs. If I push with my hand on the wall pushes back on me. If the spring pulls up on the mass pulls down on the spring, and that's what makes it stretch. So this is where you get that idea. Forces come in equal and opposite pairs. They're always come in pairs. Okay, and that's important for rockets. The next important idea is what we call momentum, and we use the symbol P to represent momentum. The arrow over it just means it's a vector, so the direction is important. The momentum is the product of an object's mass and velocity. As long as it's not going too fast, then we'd have to change it. But rockets and stuff, this is fine. So here's a soccer ball moving through the air. If it's moving, if it has mass, it has momentum. This train has a much, much, much larger mass, and it's probably even going faster, so it has much, much more momentum than the soccer ball. Here's a bird it's moving to. Its mass is a lot smaller than a soccer ball, probably, and so it could have a lower momentum. But all these objects interact differently based on their momentums. So we have force, we have momentum. What about force and momentum? So this is called the momentum principle. This says that if you have a force on an object, it changes the momentum. Okay, forces change momentum. So they're not going to change the mass. It means they're going to change the velocity. And it's the net force. I mean, that's not a really big deal here, but so here's an example. Here's a car with no net force on it. It's moving along this track, and it goes at a constant speed, so this momentum doesn't change. If I have a fan pushing on the cart with a constant force, it's going to increase the momentum. So this one has a changing momentum. It's kind of hard to see. Humans aren't really great at detecting changes in momentum. Okay, let's put this together and make a simple rocket. So here is that same cart, and I have taped to it this little ball launcher. So the thing on top will launch a ball to the right, and let's see what happens when I do that. There's a spring that's compressing in there. When I pull the lever up, it releases the spring and shoots the ball out. The bag on the right is just to catch the ball, so I won't have to go chasing it. So here I pull up on the launcher, and you see the ball got shot to the right. The cart moved to the left. There was some friction, so it didn't move at a constant speed, but you get the idea. That's a rocket. So the basic idea is I have this green car, and I made the ball red, and the car exerts a force on the ball, pushing it to the right. But forces come in pairs. So the ball pushes back on the car to the left. So those two forces have the same magnitude. And that means that the ball will change momentum to the right, the car will change momentum to the left. Now, the car has a much greater mass than the ball, so the change in velocity of the car is going to be a lot smaller than the change in velocity of the ball. So the ball shoots out really fast to the right, the car moves a little bit to the left. That's a rocket. Not a very good rocket. Okay, we can make it better. What if I had a bunch of balls inside of the rocket and I launch one after another? Each time I launch a ball, I push on it, I increase the momentum of the ball, that increases the momentum of my spacecraft. So here I'm showing the ball being shot to the right, and the arrow is the velocity. Okay, so it has a high velocity, and the spacecraft moves to the left. Now, higher velocity means a greater change in momentum. A greater mass means a greater change in momentum. But that's just one change in momentum for the rocket. I want to keep on exerting a force. So I need to have a rate that I shoot these balls at. And those are the three things that matter for your rocket. What's the mass of the stuff you're shooting out? How fast are you shooting it? And what's the velocity of the stuff you shoot out? So this is exactly what happens in a rocket, except that it's not balls, it is gas of some type that is shot out of the back end of the rocket. And I changed direction because I stole this picture from a different thing that I made. Okay. So rockets don't use springs. They actually use a chemical reaction. You have a chemical reaction between two things. Just like when you light a match, you have a chemical reaction and that makes a lot of energy and it shoots gas everywhere. Same thing happens here, and we have a chemical rocket. This is a liquid engine rocket test, and you can see all the stuff being shot out to the right is just like those balls being shot out, but it's a lot more balls, a lot faster, and it keeps shooting them out. But you don't have to have a liquid, you don't have to have a chemical rocket. Here is an ion rocket. So this takes tiny charged ions. Let's say you get some heavy ion, you remove an electron, so it's positive. You use an electric potential to accelerate that charge and shoot it out the back. Boom, rocket. Okay. Now, the mass of these things is very, very low, and you can get really high speeds, but with low mass, you don't get very high thrust. However, you can make these things run for a really long time because you're not using up your fuel that much. So these are useful in a lot of applications in space. You wouldn't get off the ground with this. Here's another rocket. This is a nuclear rocket. So the red, this is an animation I made. The red one shot out one big mass with a nuclear explosion. And the other rocket was just a conventional shooting out a bunch of little bitty balls. So you can see if you get one big explosion shooting out a large piece, you can get the thing to move. So that is possible. You wouldn't want to launch that from the surface of the Earth because then you have all these explosions and that's bad. Okay, here's a water bottle rocket. This is something that you could make on your own. So if you can't see, I'll show you a better picture in a second. There's a water bottle with a cork in it, and I pump it up with air until the thing shoots out. That was a bad water bottle rocket, but it's easy to build. Here's a much better one. This is a machine that holds it in place really well so that I can pump up a lot of air into that bottle. The air at the top is like the spring, okay, in the ball spring model. It pushes all that water out. The water is like the balls. The water gets pushed out. That exerts a force on the water, so the water exerts a force on the rocket, and it goes up. Pretty cool. These are pretty popular. Here's one that you shouldn't try. This is butane soda rocket. So you take soda in the bottle, you add butane lighter fuel on top of it, and then when you tip it over, it shoots off like a rocket. And it's dangerous, okay? But it's also kind of fun. But don't do it. So this is how it works. You have the soda and the butane. When you flip it over, the butane has a lower density than the soda. So when you flip it over, that butane flows through the soda and makes it carbonate. And it also warms up the butane, which expands. Both those things together push the soda out, and that's like your balls. Here is my favorite, also dangerous rocket. This is a liquid nitrogen rocket. So it's the same idea, but you, instead of soda, you use water, and you put liquid nitrogen on top of it. When you flip it over, the liquid nitrogen warms up and expands into a gas. That gas pushes the water out. Here's what happens. And I love this because you can see as it's falling down, it doesn't happen instantaneously. So you drop it down and then it starts shooting that water out and it goes up into the air, and that's a rocket. Okay, so that's what you need to know about rockets. I hope you enjoyed this.